Right now, above your head, there is a graveyard, not on Earth, in orbit. Thousands of objects moving faster than any bullet. You can't see them. You'll never hear them coming.
But they're there. 22,500 tracked objects hurtling around this planet at 17,000 miles per hour. And if just one thing goes wrong, it could trigger a chain reaction that locks humanity out of space.
Permanently. We like to think of space as empty, silent, endless, but the space around Earth isn't empty anymore. It's a crowded, invisible minefield, and it's been growing since the very first rocket left the atmosphere. Decades of launches have left behind something no one planned for. Old satellites that stopped working but never came down, dead rocket stages tumbling without control, fragments of spacecraft that collided years ago and never cleared. The European Space Agency described the current environment as having reached previously unseen levels of congestion.
From 11,900 tracked objects in 2015 to 22,500 by 2025, an 89% increase in a single decade.
And every year we add more. These orbits, once open, are now threaded with debris across every altitude band surrounding Earth: low Earth orbit, medium orbit, geostationary, all of it filling up.
Today, scientists estimate over 100 million pieces of debris are orbiting Earth.
Only a small percentage is large enough to track. The rest, invisible, unpredictable, and still incredibly dangerous. Because in orbit, speed changes everything. These objects travel at over 17,000 miles per hour. At that speed, a fragment the size of a paint chip carries the energy of a hand grenade. A marble-sized fragment carries enough energy to punch straight through a satellite like a rifle bullet through paper. There are an estimated 1.2 million objects in that size range, too small to track, large enough to destroy. NASA confirmed it directly. The most dangerous threat to the ISS isn't the large debris they can see and avoid. It's the invisible middle layer, dense enough to dominate risk, impossible to reliably track. But the real danger isn't just the debris itself. It's what one collision sets in motion. In space, there are no brakes, no cleanup crew, no stopping what comes next. When two large objects meet in orbit, they don't just break apart, they explode into thousands of new fragments, each one moving at orbital velocity, each one capable of destroying the next satellite it hits. This creates a chain reaction. More debris, more collisions, more debris still. The density rises until orbit itself becomes the danger. Scientists call this the Kessler syndrome. In 1978, NASA scientist Donald Kessler proposed the scenario that keeps space engineers awake at night: a cascade where debris multiplies uncontrollably until low Earth orbit becomes too dangerous to safely use. Not dangerous for some things, dangerous for everything: satellites, missions, crewed spacecraft. Once Kessler syndrome begins, there is no stopping it. No cleanup effort can outpace the cascade. Every new rocket launched into a saturated orbit risks destruction before it reaches altitude. Every satellite shredded within months. Every launch window closing permanently, one collision at a time. Hypervelocity impact tests at NASA labs confirm what the math predicted. Even a centimeter-scale fragment transfers more than enough energy to disable a multi-million-dollar satellite on contact. And we already know how fast it can happen. One collision between large objects can create thousands of new fragments in seconds, each one beginning its own independent orbit, each one a new threat. This isn't just a space problem, it's an Earth problem. Modern life depends on satellites in ways most people never stop to think about until they stop working. GPS navigation, weather forecasting, internet and communications, financial system timestamps, accurate to the microsecond, emergency services, precision agriculture, feeding billions. All of it depends on satellites orbiting through this growing field of debris. The European Space Agency estimates that even if we stopped all launches today, the debris field would continue generating new collisions on its own for centuries. We are already past the threshold of self-generation. If those satellites fail, the effects don't stay in orbit. No GPS means no navigation for ships, planes, or emergency vehicles. No weather satellites means disasters arrive without warning. The ripple reaches everywhere. This isn't speculation. The ISS has already conducted 41 collision avoidance maneuvers since 1999, physically moving a crewed space station out of the way of our own garbage. The danger is already here. And this isn't just theoretical. In 2009, a defunct Russian satellite collided with an active American communications satellite, Iridium-33. No warning, no time to maneuver. A full operational satellite gone in an instant. The result? Thousands of new fragments instantly added to orbit, some still active in debris fields today. Iridium-33 became a lesson the world noticed, but didn't fully learn. In November 2021, Russia deliberately destroyed its own defunct satellite, Cosmos 1408, a direct anti-satellite test. The result? More than 1,500 trackable fragments and hundreds of thousands of smaller pieces. The debris risk to the ISS doubled overnight. Astronauts took shelter in their emergency return capsules while the cloud passed. A government deliberately created a crisis in orbit, and the people living up there had to hide. Since then, there have been multiple close calls, satellites forced to maneuver, missions delayed. ESA satellites now average 2 debris avoidance maneuvers per spacecraft every single year. The burden is growing. And now, the situation is speeding up. Companies and governments are launching thousands of new satellites, massive constellations designed to power global internet coverage. More traffic, more risk. We're not just adding to the problem, we're accelerating it. In January 2026, the Federal Aviation Administration quietly withdrew a proposed rule. That rule would have required rocket upper stages to deorbit their debris, not delayed, not revised, withdrawn. The rule is gone. This matters because rocket upper stages are among the most dangerous debris sources in orbit. The Long March 6A broke up in 2022. 533 catalogued fragments. It broke up again in 2024. These are persistent threats lasting decades. The global framework is no better. The IADC Space Debris Mitigation Guidelines, the core international agreement, is soft law, voluntary, non-binding. No country is legally required to follow it. No enforcement mechanism exists. So why not just clean it up? The answer is complicated. Removing debris in space requires precision, advanced technology, and massive cost for objects that were never designed to be caught. Some solutions are being tested. Nets, harpoons, magnetic capture systems, even lasers. Astroscale has already demonstrated debris capture in orbit. ClearSpace has a contract with ESA to remove a specific object entirely. But none of these solutions scale to the size of the problem. Not yet. We're talking about 20-500 tracked objects, and the political and financial will to remove them doesn't yet match the urgency. The technology exists, but for now, we're managing the risk, not eliminating it, monitoring, maneuvering, filing reports, and hoping the next collision isn't the one that starts the cascade. Right now, space is still usable, satellites still function, launches still happen, but we're moving closer to a tipping point, a moment where one collision could trigger something unstoppable. Every day, without a binding global cleanup law, is another day the window narrows, another day the debris field grows, another day closer to a threshold we cannot walk back from. If that tipping point is crossed, we don't just lose access to space, we lose GPS, we lose weather forecasting, we lose the communications infrastructure that modern civilization quietly runs on every single day. The sky above us may look empty, but it's anything but. What's happening up there, right now, invisibly, could shape the future of life down here. The question is whether we act before it's too late.
If this gave you something to think about, share it. The conversation doesn't happen unless people are having it. Subscribe if you want to keep going deeper.